So next week you're going to be doing an experiment looking at a thing called Hooke's Law. And it's where we look at the relationship between how much mass or how much weight we hang off a spring and how much it extends or stretches by. And we should be able to find a relationship between those. So I've got some data just on the internet here so that we can look at how we would graph that information. The principles of how we graph this are the same for anything where there is a relationship, which is something like to find the effect of doing this to something else. So we were looking at to find the effect of kicking angle on the distance that the rugby ball travels. So that would have to be done as one of these graphs as well. And one of these graphs is a line graph. So whenever you're looking at a relationship, we want it to be a line graph. And there's a few different rules on this and a few things to remember. So I'm going to go through those and how you construct a graph. Now you'll be given graph paper, not a blank bit of paper like this to do a graph. So it makes it a bit easier than what I'm going to do. I'm going to have to use my ruler a lot for this. You won't need to so much until right at the end because it'll already be on graph paper with what we call a y-axis, the up and down one, and an x-axis, the one that goes across. But it's knowing what to put there that's really important. The first thing that we need in a graph, once we've got the axes in place, so these lines with the arrows at the end, is we need to put a title for it. So for this particular experiment, we're looking at the effect of mass on the extension of a spring. So that's what we have to write. Now when you get further up in physics, that would be just called Hooke's Law because people know what that means. But for now we've got to put it a small sentence. And it's really good to start with the effect of, you change the word mass for whatever you changed on purpose. So for our rugby kicking, what did we change on purpose? Angle. So you'd make that the effect of angle. And on spring's extension is what we are measuring in this experiment, how much it's stretched. So in our rugby one, what would that be changed for?
Distance travelled.
Fantastic, distance travelled. So it'd be the effect of angle on the rugby ball's distance. Okay, so that's how we'd write a title for our rugby ball one. For this one, it's a little bit different. So the things I've underlined in red are the only things that you actually really need to change when you're thinking about, how do I write a title? I don't know. Just have this method. The effect of something on something else. And then you've got a good title. The next thing that's really important is choosing what of these two things, mass or extension, are going to go on which of these two lines. And this actually is quite important. The convention, the thing we're meant to do, is we're meant to put the thing we changed on purpose, the independent variable, the thing we changed on purpose, on this bottom line here. Okay? So, in this, what one of those do you think the experimenter changed on purpose? Mass. Good. So put mass, and we have to put the unit, which is grams, in there as well. It's really important to include the unit. If you forget the unit, then your graph's not actually worth much at all. Okay. The other thing goes on the y-axis, what we call the dependent axis, the one we measured. So that's going to be the other one, extension. And again, don't forget the unit. Cool. So if this is our rugby experiment, what's going to go on the bottom axis? The degrees, the angle. Okay, angle would be the word, and in brackets you'd have degrees, just that little degree symbol. Cool. What would go up here? Distance. And what are we measuring our distance in? Meters. Fantastic. Okay, so we know how to label that for our rugby one as well. Right, the next thing is to try to work out a thing called the scale, because it's actually got to show a relationship by being a line of best fit or a curve of best fit. And that's a bit tricky to do for the extension, but it's actually quite easy for this one here. What do you notice the differences between each measurement? 30. So if I counted up in 30s down here, that would make quite a nice scale, wouldn't it? Okay. For our rugby one, it's going to be a little bit harder because our angles were all over the show because we couldn't control it very well. Okay, so you have to come up with a value, maybe every 5 degrees or something like that. So maybe go, 0, 5, 10, 15, 20, all the way up to, I don't know, about 60 degrees.
When you do degrees, can you start from like maybe 35?
Right, no. In some subjects, like history and geography, sometimes when you graph in those, you can do a little jaggedy line at the start, show that you've jumped quite a bit.
Yeah.
We're not allowed to do that in physics, and this is a physics investigation.
Okay.
Okay, really good question. Thank you for asking that. So, we're going to count up in 30s, and we have to start at 0. We can't just start at 60, which is what your idea would have suggested, which is a good idea. We're just not allowed to do it. So, we're going to start at 0. So, the first thing I want you to get into the habit of is put 0 on the corner. So, that's 0 for the y-axis, 0 for the x-axis. Then you're going to need to measure or count squares. You'll have maths paper, so you can count squares. Much easier. I don't, so I'm going to have to measure along the bottom. I've got to get to at least 180, which is at least 6 30s. 6 times 30 is 180. So I've got to get to at least 6 marks along here. And they've got to be evenly spaced. So I'm going to measure it, and I find that I've got I don't know how I did that so accurately, 500 centimetres of graph, okay? So if I need to have there to be at least 6, oh, that's awkward. I'm just going to go every 5 and have 10. 10's bigger than 6, isn't it? So I'm going to go every 5 centimetres, I'm going to put a mark. Okay, so it might have been every 5 squares on maths paper. Oops, nearly missed one. Okay, I've run out, so that's cool. Then I'm going to put the numbers. Now, what did I say I was going to count up in? 30s. So my first one is going to be 30. I don't have to put the 30 there, though. I can just number every second one. So this would be 30, then 60, 90, then 120. Whoopsie. 150, 180. Now I know they've got nothing beyond 180, but I'm still going to number them. 210, 240. Okay. So rather than cramming it up with lots and lots of numbers and getting confused, I'm just numbering every second one. But you might want to number every single one of them. Okay, you might find that easier. Okay. Now I've got to choose a scale for here. What's the biggest number that's going to go up here? 5.9, which is roughly 6, isn't it? So I'm going to measure the height there. Whoops, it's a bit easier if I do it this way, possibly.
1, 2, 3, 4, 5, 6.
Yeah, just go 1, 2, 3, 4, 5, 6. It's just over 500 centimetres as well. So I can't just go every 10 centimetres, can I? What do you reckon? Should I go with 5 again? Yeah, would that be nice and easy? Again, you'd choose a number of squares that makes it easy to work with. Try not to work with 3 squares because thirds are really hard to work with. Try to work with 4 squares or 5 squares or 10 squares. Okay, so just get that lined up so that I've got it sitting on a 0 to make my life easy. Okay, so we're going to go every 5 centimetres. 1, 2. And I've got way too many lines, but that's okay. It's having not enough lines that's a problem. Not enough marks. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got more than enough, haven't I? Because this doesn't go up to 10, so that's good. If I had gone too much higher, say if this had got to 20, I probably should have redone it and halved everything. So I want to be relatively close to this number. To be honest, it's probably a bit far out, but for ease, we're going to go that way. Okay, the next thing is to work out where to put the marks. So I've actually done what I think is the hard bit of the graph. I've actually done the scale, the labels in the right place, and I've done the scales. The scale is the hardest skill to get right. Okay, so we're looking at our biggest numbers, we're looking at how big our axes are, and we're going to try and make it fit so that everything's evenly spaced. Cool? Right, so my first value is at 60 grams. So what I'm going to do is I'm going to do, this would be in pencil because you're going to rub it out later. Oops, hit myself in the face with the ruler. And I'm going to go dotted line where the 60 is. Okay, because that's my first value there. It matches up to 1.5. So if that's 1 and that's 2, where would I expect 1.5 to be? In the middle. Cool. So I could measure it. I know that these are 5 centimetres, so 2.5 centimetres in is there. And I do a dotted line. Again, pencil this would be. They're what we call construction lines. And where they meet is where I need to mark a point in my graph. Now, in year 9 and 10, you could have done that as a dot, a circle, a cross, a plus sign, literally just a dot, and you would have got away with it. In year 11, you're not allowed to do that. It must be a cross or a plus. I like doing a plus because then I can go through that line and through that line, and where they meet is the point. Pluses or crosses. Crosses being diagonal. Yeah? I like pluses because I think they're more precise. They give me that point that it goes through better. Cool? Okay. And I keep doing this. Then what I'll do is I'll rub out the bits that are going to be in my way. They're going to be in my way, so they've been rubbed out with an eraser. I'm going to keep those bits there because they show the examiner how I got that point, which will help me get marks even if I've made a small mistake. Okay? Because your method is correct, your way of doing it. So then I carry on, 90 with 2.5, and now I'm just going to do it roughly, okay, because I want to carry on with the video. But 90 is our next line here, even though it doesn't say 90. How do I know that's 90?
Because you jump 30.
Jumping in 30s, well done. So 90, we go with 2.5, and I reckon 2.5, if that's 3, 2.5 must be there.
So we don't have to do the dotted line for all.
Do it for 1 at least. Okay, I'd like you to do it for 2 or 3, but you can see how I made that with the ruler. Boom, boom. And that's why I like pluses, because that made a plus straight away, didn't it? Okay, 120, 3.6. 3.6 is a bit harder to work out, but let's see. I can estimate it. If that's 3 and that's 4, it's going to be about there. So I'll put my up line there. Then I could measure this if I want to. Again, sorry for speed. The haste, I'm going to do it here. And look, whoops, I made a mistake. I missed. So all I need to do, just freehand is fine. Just go through where they'd meet. Rub out the rest. Okay. 150, 4.7. Oops. And last one, at least 185.9, which is basically 6, isn't it? Okay.
So you don't round.
No, well look, not if I can help it. Sometimes you're going to have to round off. And that's completely fine. And that's why we do the construction lines for some of them, so that we can show the examiner, the person who's marking, how we've done it. Now if I have a look at those, do they look like a curve or do they look like a straight line? Okay, if they look a bit like a straight line, you have to make it into a straight line. It's what we call a line of best fit. So what we're going to do there is we're going to draw a line that hits as many of those crosses or pluses as we can. It doesn't have to hit the middle of them, okay? But it has to try to hit something of that plus. So keep the size of the pluses consistent, so quite small. Ideally it should go through 0, but don't force it to go through 0. If it doesn't, it doesn't, okay? So I get my ruler and I try to swing it through, and it's pretty tricky to get it to hit. There would have been great, wouldn't it? Shame about those last two messing us up. So I think a line of best fit, some above, some below, is going to be
Why
around.
do you have to get it to hit all of them?
You've got to try to, that you won't necessarily succeed.
But why?
This is because of errors in the experiment that we couldn't control. Okay, and I think someone before said that the spring might be stretching a little bit.
Couldn't
that
you
could affect
just
it.
draw them like it's a line graph, so you couldn't you just draw it? Point
Oh, dot to dot?
Yeah.
Right. Because we're trying to find a relationship, it's either got to be a smooth curve, okay, so a curve up or a curve down, or it's got to be a straight line. Those are our only choices. Okay, really good question as well. So we're not allowed to just go dot to dot. Okay, good question. So here we've got a line of best fit and our graph is completed. What we're going to look at later, and not on this video, is how we find the equation for this graph. Okay? And in maths, you might have heard something like this. Y equals mx plus c, or y equals mx is how you find the gradient. That's the equation for a graph. And this, so it wouldn't be y. What's on our y-axis? Extension. So it'd be extension equals m is the slope of the line. We'll do that later. What's on this axis? Mass. And c is where it cuts through the y-axis. Well, actually, this year we're going to say don't worry about that because it is important, but not this year. So we're just going to say that. So m would be slope. And we're going to work out how to do that probably later today or tomorrow. Once you've got this equation, by the way, and you can just use the words, we're putting in a number for where it says slope, and we'll work out how to do that later. If you've got this equation, that actually will help you get merit or excellence. Okay? If you can construct the graph, that's really only achieved merit stuff. Okay? So, just go through that again quickly, the rules. We started by, we hit our axes. What was our first thing that we did?
Y and X.
Further up.
Oh, the title.
Title, cool. And we've got a way to write it, the effect of something or other on a something or other. Yep, so we're just going to change those nouns. Then someone said the right thing for the second thing. We put a 0 on the corner. How do we decide what goes along the bottom? It's what we changed.
Independent variable.
Good, the independent variable, the one we changed on purpose in the experiment. We made sure we had a scale for it. We counted in 30s in this case for your experiment. With the rugby, you might count in 5s for the degrees. The other variable, the one we measured, the dependent variable, goes on this up and down axis. And again, we need a scale. When we start plotting the data, this is the data, this is it being plotted. How did we do that? Lined it up, and we used little dotted lines with pencil, what we call construction lines. And what shape does our plot have to have for each point? Cross or a... Good. So a plus or an X. Fantastic. Easiest one to do is a plus, isn't it? So you can see how I did that in the video. And then at the end, if it looks like a straight line, it has to be what we call a what? Line of... Good. If we think it's a curved one, it has to be a smooth curve, either going that way or going that way. Okay? And that's basically it. Those are the skills that you need for your graphing, for your rugby experiment, and for your internal assessment, and for the experiment we're doing next week.